Creating a Workcell for import to Robot Studio using Solidworks. In this video, I'm going to go through how to set up Weldiment profiles, create a 3D sketch, and turn that 3D sketch into a simulated robot work cell that's accurate to the actual work cells that we have in our robotics lab. Let's get started. So when we first open up Solidworks, the first thing that we need to do is we need to make sure that we have our Weldiment files in place. So what we're going to do is we're going to go under the settings in Solidworks here. So we go to Tools, Options, and we're going to go down to File Locations here, and we're going to add an additional Weldiments folder. So in our program, I've actually created for you guys a folder that contains a variety of different Weldiment profiles that we might want to use within our lab. And this folder will grow over time as I find more and more components that we can utilize. So I'm going to add, and the file location that we want to grab is we want to go to the O drive, and we're going to go to Student, M&A, Data, MET Automation, Solid Models, and then we're just going to select this Weldiments folder. We don't need to select anything under it. We want to select the primary folder because underneath this folder are a specific folder structure designed for SolidWorks to build proper Weldiment profiles so that we can keep track and organize things. We're going to say OK. SolidWorks will ask us if we want to add this to the search path, and we want to say yes. And then now we're going to go and we're going to create that 3D sketch. So I'm going to go File, New, and we're going to create a new part. For this, we want to make sure that we're using millimeters, grams, seconds for our configuration. So make sure that you've got mmgs down at the bottom here. If you don't, click this little up arrow and make sure to set it to millimeter, gram, second. The reason that we want to do this is by default in Robot Studio, absolutely everything is in millimeters. So we want to make sure that our part that we're building is in millimeters. So when we import, it imports with the correct scale. The next thing that we want to do is we want to select our front plane here. And the reason that I want to select my front plane is because we're going to be building everything off of the front plane. So the front plane will actually be the floor of our work cell. And the reason that we're doing that is because the Z-axis is actually up in Robot Studio. X positive is, if you're facing the robot, X positive is kind of towards you. So the door on the work cell will actually be at the most positive location in the X of your work cell. So this is something that we want to keep in mind. Depending on what it is that you're doing, this may be different, but that's the basis that we're going to go off of for setting up this particular configuration. So now I'm going to go, and I've got my front plane selected, and I want to select 3D sketch. Now, normally, there's a couple of things with 3D sketches. 3D sketches can be kind of challenging and a little bit frustrating to make. So if you want to do this by making your own sketch planes and just do a simple variety of 2D sketches, you can do that as well. I'll show you how I go through to make a 3D sketch in this video here. All right, so I've got my 3D sketch. I'm going to right-click on my front plane and go Normal to, and I'm going to make the floor. I'm just going to drag a rectangle out here, and don't worry if it's not at the origin. We're going to center that up in its correct location here in a minute. And what I want to do to start off with, and it's important that you do this before you add construction lines, by the way, otherwise it messes with your view. I'm going to say that the front across my cell right? Notice that this is dimensioning the width of the x-axis of our cell, or the wall that's across the x, or across the x. So I'm going to go in here and I want this to be 2,500 millimeters. And I want this one to be 3,000 millimeters. All right. And we're going to bring that dimension back over top of that, just to make this a little bit easier. Now, the next thing we're going to do is we're going to turn off dimensioning. We're going to select this whole rectangle because this is the floor and this is actually my reference. So I'm going to say that I want it to be for construction, because I just hate when that floor ends up in there. Then we're going to make a center line off the mid plane, or the middle of my frame. Actually, you know what? Do it with just one line, because the thing is, I know that my pedestal, which is what I'm going to use as my center reference for my whole frame, I know my pedestal is centered left to right, if you will, when you're looking at the robot frame. So I'm going to grab a hold of this line, pressing and holding Control. I'm going to select my origin, and I want to make these coincident. And then the next thing that I want to do is I'm going to move my frame a little bit this way. And I know that the front of my frame is approximately 2,500 from where my pedestal sits. So the front edge of my pedestal sits about 2,000. Actually, it's 2,250, so I'll fix that. There we go. So now I've got this all set up, and this is the kind of basis of where things sit for my Workcell. So now we're going to build all the lines that are going to show us where everything sits. So to do this, I'm going to start by building the front of my Workcell, which is actually, in this case, in Solidworks, going to be on the right plane. So I'm going to go normal to my right plane. And the reason that I'm doing this is because it's really hard in a 3D sketch to get your line going specifically on one axis or another, or getting it to go the right direction in one axis or another. So what I'm going to do is, by going to my right plane and then shifting my view a little bit, so I'm going to turn a little bit here, turn a little bit there, so I'm still primarily looking at my right plane. Then I'm going to grab this front corner, and I can easily snap out on the Z-axis. Then I'm going to put something along here, and I'm going to close that in. Now I can go to this line and say, I want you along the Z. That'll lock it in so it's vertical on the Z-axis and not on the Y. And then I'm going to say, you, I want along the Z. And by doing that, these two lines are going to be kind of fixed on the Z-axis. And then I want to say you, and actually, you know what? I'm going to leave those two for the moment because I want to build my back two lines as well. Bring that out. And bring that down. Make sure this goes to the back there, which is hard to see. Twist this a little bit. There we go. Then I'm going to grab this line and say he's along Z. Grab that one and say he's along Z. And then lastly, I'm going to grab all four of these. And once I grab all four of my lines, I'm going to say that they're all equal. That way I only have to dimension the height of my work cell once. And then now I can connect this line across the top and connect this line across the top. And now I've got the roof of my work cell. Don't forget, I'm still looking at the front. So I'm going to grab a line across here. And because this is going to be my door, then I'm going to put a line here and a line here. And I want to make sure that this line, that line, this line are all parallel with the floor. And I want to make sure that my door is parallel with the other side of the door. Then I'm going to make sure that my roof line is parallel with the floor here. Make sure that this roof line is parallel with the floor here. And the back brace is parallel with the floor there. Oh, I got something extra selected. I selected my dimension line. There we go. Now those are all set to parallel. Then I can go in here and I need to build a bar across there. And I need to build a bar across there. Pay attention to which line highlights, by the way, when you're doing this, because the highlighted line will tell you what you're connecting to. And we'll make sure that that is parallel with the floor. And this is parallel with the floor. And now I can go in and throw some dimensions on this. So I'm going to adjust my view a little bit here so it looks a little bit more like what we would see with the Workcell. So, a little thing to mention, when I do all of these lines, I've actually dimensioned all of my lines based on the exterior of the cell itself. In doing so, this makes it a little bit easier for me to know that all of my extrusion frames are going to be inside this frame that I've made. So I'm going to add some dimensions. I know that the door itself is, let's say it's meter or 1.25 meters, and the first cross brace is, actually, I guess before I do the cross brace, I need to give an overall height. The overall height of my work cell is 3 meters. There we go. The first cross brace is at let's go 2 meters. Nope, not 2 meters. Let's go right about there. And this is going to be the top of that frame. And this one here, we're going to say it's the same as well. There we go. This one here happens to be 1250. No, this one happens to be 2000. Or sorry, in the midpoint, it's 1500. Go. And now we've got our fully dimensioned sketch. And we'll exit our sketch. And there we go. There is our simple work cell. So at this point, what we're going to do is we're going to go under the Weldiments tab, if you're not already there. We're going to select structural member. And because we added that path earlier, we should have the ability that we can select under here and select Bosch Rexroth. And then we can select the 10mm slot, and we're using the simple 45 by 45. Now, the main difference between the simple and the regular 45 by 45 is just quite literally, I've made a simplified version so that most computers should be able to run these Weldiment profiles without any issue. And what we're going to do is we want to say transfer the material from the profile, and we're going to build our first group being the whole top of this Workcell. Let's do that now. Wait for a second here for Solidworks to catch up with us, and there we go, we see our first item. So we're going to go locate profile, and in doing that, we're going to say it's going to be based on this top corner. There we go, because I've measured to the outside edges of my Workcell, remember? And now that that's selected, I can pick all of my other profiles around here. And there we go. Now, don't worry about this failed to trim message. We're going to fix this here in a minute. And actually, the way that we're going to do this is we're going to go in here. Actually, I'm going to add all of my various profiles. And I may just, or I'll do this right quick here. So what we're going to do is we're going to say a new group. Each time you make a new layout or a new section of profile, you want to do a new group. So I'm going to start by doing my verticals. And each of these verticals, because they're all going to be placed different, I need to do a new group for each vertical. Oops. Accidentally put that second profile under the first group, so I'm going to get rid of that one. Go. That's better. The reason that we want to do each of these under a separate group is it makes it way easier to trim. But in the same sense, we also don't want to do this under individual different structural member groupings, because if we do, then later on, if we wanted to change this from the simple profile to the more complex one so that we can go in and perform structural simulations or anything like that, we really lose that ability to very easily change everything all at once to a new profile. So I'm just doing this for simplicity of future operations. And on these cross braces, I measured to the top outer edge. So that's why I'm using that as my profile. And you'll notice some of these are going to trim properly. We're going to fix those that don't in a couple of different ways. So I'll show you how to do that in a minute here. And don't worry, this takes a little bit of getting used to work with Weldiments in SolidWorks. I think you've gone through this in one of your SolidWorks classes before. This one and this one here, they're both placed off the same, so we can put them both in the same group. We can do a locate of the profile. And there we go. Now we've got all of these selected, or all of these items in place. So now what I'm going to do is I'm going to go over here to my top group, group 1, and I'm going to adjust this slightly. It's going to be a little bit hard to see here. But what I want to do is I want to play around with these segments. So right now you can see that the longer section is the one that's shown with this highlight. I want to change the end butt of this particular corner. If I select off of this, you notice this one's kind of extending through the wrong way. I'm going to adjust that so the rear is the longer section. And if we want to adjust just an individual corner, so this corner looks good. This corner over here looks good. But this corner over here looks wrong. So I can select the little purple circle, and I can say just this individual corner, I want to flip how it butts up. So when I select that, it should fix it. There we go. We can see the long length across the back is the one that extends through. And then my suggestion is when you do that, go double check all of your other ones that you may have messed with to see if it fixes them. And then we're going to say OK, and that's going to create all those structural members. This may take a little bit for your computer to process. And at this point, I'm going to hide my 3D sketch because I don't like looking at it. And I'm going to go in, and you can see now I've got this frame here and this frame here are good. They're in the right place. However, the vertical post goes up through it. And that's obviously not what I'm going to do. So what I'm going to do now is I'm going to use the trim extend command. So I'm going to trim all of my verticals. So I'll select all of my verticals here, and I'm going to trim them based on the underside of these frames. So I'm going to zoom in a bit, change my view. So I'm looking at the underside of my frame, like this. And I'm just going to pick this face. And I'm going to do that on all of my verticals here. Then I'm going to zoom out, and we want to make sure that we've got all of these 4 arrows for the 4 outer edges, and we want to make sure that it's saying it's going to discard the top and keep the bottom. And if it is, like we've got here, we will hit OK. And if not, you can click on this to change the keep or discard. But this is good, so I'm going to say OK. Now when I zoom in and I look at this, the vertical is good, but I notice that this corner is not good. So I'll see if that corner is not good either. Actually, none of those corners are good. So you know what? We're going to fix all of those here in one. So this pole and this pole, if I take a look at my cross beams, these cross beams are good. So it's just these top 2 that are messed up. So we're going to go based on face or plane. And I'm going to grab trim to that face. And the reason that it's having some issues with this, by the way, is because there are literally so many faces in this profile. It's hard for Solidworks to assume what type of end feature that you want to actually attach your material to. If this was box steel, it'd be way simpler. So I've got those 2 done, and now The last part are these, and these are all messed up too, so I'm going to go trim extend. I'm going to grab those two. I want to trim those two, and I want to trim it to that face there. And I want to trim it to that face there. There we go. Now I can say accept. And I have my robot Workcell frame. So I'm going to save this. And I'm going to save this in a folder that I have on my desktop. Where you save yours is up to you. But on my desktop, I've got this folder called Robot Studio Video Demos. And I'm going to create a new folder called Demo Cell. Now, keep in mind, you cannot import your solid model file into Robot Studio unless you specifically paid for that option. So instead, what we're going to do is we're just going to make this as a solid part, so it's easy for us to go back, edit, change dimensions, adjust the base, positioning, all of those other different things later on if we need to. And what we're going to do now is once we've saved it once, we're going to do a file save as, and we're going to save this as a ACIS or .sat file. This .sat can be imported by Solidworks, and it maintains all the dimensioning, everything like that, and keeps your origin at the same origin. So we're going to save that. And now, once this is saved, you can go ahead and you can import this into SolidWorks, or sorry, not into SolidWorks, into Robot Studio, and continue working on with your various work cells. I hope this was informative. Thanks for watching, and we'll see you in the next one.